Remember, was it 2 days ago? We had that problem. We had the I on there, and I said I wasn't sure when the next lesson was when we do I, but I knew it was coming up soon. Well, it was sooner than I thought, so it's right now. So, oops, I am recording. I forgot to put my microphone on. There we go. That should sound better. All right, so let's take a look. So we call this whole thing complex numbers. We don't call it complex because it's like really hard and really difficult. We think of complex, meaning that. Okay, it means complex because it's a combination of two things. Like in English class, do you remember you did simple sentences, compound sentences, and complex sentences? Actually, the compound sentence, I think, was more difficult than the complex sentence. I forget off the top of my head. I always think when I say this that I should go back and look at the difference between a complex and a compound. Anybody remember what a complex sentence was? Wasn't it a combination of two simples or something like that? Anybody remember? You haven't done grammar in a while? Anyway, you remember that though, don't you? Yeah. Simple sentence, compound, complex. This is kind of the same thing. It's just a combination of two things. So basically, a complex number is a combination between a real number, which that's what we've been using pretty much our whole lives, our real numbers. Okay, so any number on a number line is considered to be a real number. So a complex number is a combination of a real number, I'll just write that down, a real number and an imaginary number. And we talked about that a little bit. God, really? Right in front of me? So a complex number is a combination between a real and an imaginary. Now, a real number in math, we assign it the letter A. All right, the letter A is a lowercase a. We use that to indicate a real number. All right, an imaginary number, we use the letter I, but we're also going to put a number in front of it. We'll put a B. We'll talk about this in a second. And then we put an I. So this right there is a complex number. It's got a real part, and it's got what? An imaginary part. All right? So that's what a complex number is. It's just a combination between two different numbers. Let's talk about the imaginary part. We know about real numbers. We've been using real numbers our whole lives. But we haven't been talking about imaginary numbers. We did mention it the other day, so I'm going to just go through it one more time. So we use the letter I to represent an imaginary number. And we should know from our little talk the other day what the I is equal to. Do you remember what it's equal to? -1. Just -1? Square root of -1. That's right. You think, well, that's weird. I thought we couldn't take a square root of a negative number. Okay, because we used to say like no solution or something like that, right, if we had a square root of a negative number. Because if you think about it, again, I mentioned this the other day, but I'll say it again. When you take the square root of something, like the square root of 9, what is the square root of 9? It's basically 3, right? You could put plus or minus, but it's 3. So what does this mean, though, the square root? It means what number multiplied by itself, everybody hear me? Square root means what number times itself is equal to 9. Well, 3 times 3. So technically, it is plus or minus. So it could be positive 3 times positive 3 equals 9, agreed? Or it could be what? Negative 3 times itself, which is negative 3. That's also equal to 9. But can you have a negative times a positive, and that will give you a positive number? No. All right? So you can't have two different signs. So right here, can I take the square root of a -1? No, because I would be asking what number times itself is equal to -1. Anytime you take a number and multiply by itself, you're always going to get a positive answer. There's no way I could get a negative answer if I multiply two positives or if I multiply two negatives. Agreed with that? Yeah. So that looks like it doesn't work. But it's a different type of numbering system, all right? And this is the imaginary numbers. We talked a little bit about this. I had a friend that worked at Boeing, and he used imaginary numbers to figure out things. Mr. Rao had mentioned that imaginary numbers takes a problem that could be really, really, really long and it kind of condenses it. It makes it so much shorter, okay? So imaginary numbers can really, really help make things a lot easier for us, all right? That's all I'm going to say about that and the practical use of it. You've got Google. You could look it up and say, where do people use imaginary numbers? And I'm sure there's probably videos on it. I actually did. I watched a video of a guy that talked about it, and I thought about showing it in here, but then he went like way off the deep end. I have no idea. It was just a YouTube search, and I don't remember who he was. But it was good. It was interesting, but I thought he would have lost you in the first 2 minutes, okay? So I'm not going to show it to you. But you could look it up if you wanted to, all right? But we're not going to. All we're doing right now, this is high school. We're just learning the basic stuff, the real basic stuff about imaginary numbers and complex numbers, okay? By the way, we call this the standard form. So I just thought I'd throw that in there. It's the standard form for a complex number, okay? So that's what it is. All right, now we can do a bunch of stuff. Just like in regular numbers, real numbers, we can add, subtract, multiply, divide. We can do all that stuff with imaginary numbers as well. So let's show you how we can add complex numbers, two complex numbers. So if I said a plus bi, now if you look at it, it looks like two separate numbers, doesn't it? But technically it's one number. It's one complex number. Remember, a complex number's got two parts to it. It's got a real and an imaginary. Okay? So what if I added it to another complex number? We're going to use different letters, c plus di. This is still a complex number because no matter if it's a or b, we don't absolutely have to call the real a and the imaginary b. All right? But this is just a number that's by itself. That's a real number. This one is with the I. All right, so we can do it like that. So basically what you do is you just add all the reals together and then add all the imaginaries together. So again, which ones are the real numbers here? Which is the real part of this? It's the A. It's just the A. What's the real part of this complex number? It's just the C. So if I add the two together, the two reals together, it's not AC. That would be A times C. You're adding them. What would it be? Just A plus C. That's right. Everybody see that? And I'm going to group them. I'm just going to put them in a parentheses just so they stay together, okay? Now I need to add the imaginaries together, all right? So I've got a BI plus a DI. So what can I write there? Plus BI plus DI. But we're not going to write it just like that. A complex number, we want that I sitting out there by itself. So let's make it a little bit nicer. Plus, what does this thing right here have in common? In fact, we're going to factor. What's in common with both of these things? There's an I in common. Agreed? Okay. Normally you would put it in the front, wouldn't you? Okay. But we're not going to do that because remember how we write it? We always take that I, we stick it on the end. So what I'm going to do is I'm going to factor out the I, and what's left if I factor out an I? Just a P plus B plus D. So this right here is how you would add up complex numbers. We're going to do an example in a second, all right? But let's do a subtraction, all right? We did addition. Let's do subtraction. Or we're going to use the same exact letters. So it's A plus BI, but this time we're going to subtract a C plus DI. And you'll find out it's pretty much like you think it's going to be. So first of all, look at this minus right here. That minus is going through both of these. Even though it's one number, it's got two parts. So we're going to subtract the C and we're going to subtract the DI. So I'll tell you what, I'm going to write it underneath it here. So I could write A plus BI do I want to do that? I don't think I want to do that. Let's just let's not do that. I think that's going to be more confusing for you. So let's just do this. Let's add these together. So what do I get? Let's add the what parts? Add the what parts first? What goes first? The real parts first. So it's A minus C, right? When I say add, it's like plus a negative, right? Which is B minus. So add or subtract. So add or subtract the reals first. So that would give you what? A minus C. Agreed? Now I'm going to put a plus here for a reason. Yeah, let's just do that. Now let's add the imaginaries together. So what do I get? I get bi. What would that be? Plus a negative or minus di. So it would be bi minus di. Everybody see that? Okay, because of that minus right there. It's being distributed through both of these, correct? So it's bi minus di. Okay? Now, we just make it look a little bit nicer, though. I don't want the I with both of these. What am I going to do with that? Factor it out. And with I, with the imaginary number, I always put it on the right instead of the left. We're used to factoring and putting the thing that's the greatest common factor on the left, but this time with I, we're going to always put it to the right. And then what's left inside of here? It's just b minus d. All right, so that's how you subtract. See, it's a minus c, b minus d, instead of plus and plus. Yeah, it's a general form. It's not really a specific question, but it's just a general way to add and subtract. So this is addition, and this is subtraction. Maybe a little bit, not too much. We got some examples to do, though, with these, okay? Go ahead. Go. I'm sure it is. All right, let's do a couple examples with some actual numbers instead of just the A and the B stuff. Let's put some numbers in here, okay? This is example 1, 1A. So here we go. This is the kind of stuff you'll see on the homework.
Example 1.
Plus negative 2 plus 3i. All right, so here we go. Should be pretty easy. They're two complex numbers, right? So what do we add first? We add which ones first? The reals. We add the reals. Which ones are the reals here? The first one, the one that's not with the I, okay? So it's 3 plus negative 2. I'll tell you what, I'm going to show every little step here, okay? 3 plus negative 2. We okay with that? So I added the reals, put a plus. Now let's add the imaginaries. What is that? 5i plus 3i. Now look, you should eventually, very soon, if not right now, be able to go from the first step to the answer. All right? I'm just doing this just to show you what we're adding together, okay? This is basically just for teaching purposes. So what do I get? 3 plus negative 2. What's that? It's 1, and then a plus. Now I can add these together. They're like terms. Even though I means something specific, like a square root of negative 1, you can still add it as if it was a variable. Okay, it's not a variable because it stands for something very specific. Okay, but we can add them as if it was a variable. So what's 5i plus 3i? 8i, and that's it. It couldn't be easier. It's already there. It's already out by itself, right? Because I can add those together since it has an I, and now it's over there on the right-hand side, just like we did before, and that's your answer. It's got a real part. It's got an imaginary part. What's the whole thing called? What kind of number is the whole thing called? It's a complex number, but a complex number is made out of two types of numbers, one real, one imaginary. Okay, this is your imaginary part, the 8i. This is your real part, the 1. All right? Couldn't be easier, could it? Let's do another one, but this time we'll do a subtraction. Minus 3 plus 6i. Okay, here we go. So let's just add the reals first. You think we can do this in our head? Let's do this in our head instead of writing that intermediate step, okay? So what's it going to be? I'm going to add the reals together. So it's 6 minus what? What's 6 minus 3? It's just 3. Now let's add the imaginaries. I got 4i minus 6i. What's 4i minus, even though you see a plus here, remember this negative is being distributed through, right? So it's 4i minus 6i, which is negative what? 2i, and that's your answer. It's like baby stuff now, isn't it? Yeah. What do you think? Guess what else we can do? We can add, we can subtract. What else do we? Let's multiply. So I'm not going to give you some kind of fancy formula with the a plus bi stuff. I'm going to go right to the example. So this is example 2. They only give you one example. Here it is. It's 5 plus 3i. Now this time we're multiplying. There's no plus or minus in between. All right, there it is. What do you think? This should look vaguely familiar. Not vaguely. It should look very familiar. What do you think we're going to do with this? Pretend the I was just a variable. Pretend it was an X. What would you do? Distribute. FOIL. Right, in this case it's FOIL because you got a binomial times a binomial. But technically, Aspen was right, it's distributive property. So let's do that. Let's distribute. So 5 times 2 is 10. That's the first. Remember first, outside, inside, last? That's the first. The outside is what? Multiply them together. 35 what? I. Okay, that's the outside. Now we do the inside. What's that? 6i. And then we do the last. Now, we got to be careful with this, and I'm going to show you something before we get to this that we can do. I should have shown you this earlier, and I just forgot. So what do we get? Plus what? 21i squared. Now, let's talk about I squared for a second. What did we say I was equal to? -1. Square root of -1. Square root of -1. It's not -1. It's the square root of -1. Big difference. Now, what if we did this? What if we squared it? What would it get rid of? Watch. If we squared this, everybody looking? So if I squared the I, I'm squaring this over here because that's I, right? Would you agree that that's I squared? But what happens to that square and that square root? They cancel each other out. That's right. So what's I squared equal to? Boom. What? They cancel out. What's left over? -1. So I squared is equal to -1. What do you think of that? So anytime you see a I squared right here, what can we change it to? A -1. Remember, I squared is -1, not I. I is the square root of -1. I squared is just the plain real number, -1. So we took two imaginary numbers, multiplied them together, and we actually get a real number out of it. It's kind of weird, isn't it? But that's what happens. So now let's do the rest of this. It's 21. That's what I said. My pen just didn't write it down. All right, so let's go through this now. Let's do something with this first before we do it. Well, I tell you what. Let's make that 10. We can add those together. What's that? 41i, right? And what's this going to be? This is going to be plus 2 times -1. 21. Why do I keep putting 2? It's 21 times -1. All right, and so what's that going to be? This is going to be, I'll write every step, okay? You won't have to write all these steps, hopefully, but I'm going to write every single step here. What's this going to be? -21. Now, we do the reals first. Always do the reals first. So 10 minus 21 is -11 plus 41i, okay? And that would be the answer. So really, it's just regular FOIL, except when you get down to the I squared. But that wasn't that hard, was it? I squared? Okay, it's kind of nice. I squared just comes out to be a regular -1. All right? This should be memorized right here. If it's not memorized, you can always memorize what the I is and then go from there.
So does this get harder?
What do you think?
Yeah, but you guys, when we did this, you were like, it doesn't get that bad.
Well, but it does get a little harder. Okay, I was going to do something else, but I can wait and do that later. Let's do something else. Yep. We talked about this before. Do you remember talking about the conjugate? Remember that word? The conjugate? I think it's when we had a, like if you had 2 over 1 minus the square root of 3. You remember doing this?
Yeah.
Of course not. So, in order to get rid of the square root, we multiplied by the conjugate. What did we do to multiply by the conjugate? 1 plus the square root of 3. Then we did the same thing to the top. Any of this coming back to you? We did this. We had a test on it, for goodness sakes, okay? And then the reason that we did that, the reason we multiplied this by its conjugate is so to get rid of the square root. Let's see what happens. Let's do some FOIL on this. 1 times 1 is 1. Okay, the outside would be plus the square root of 3. Agreed? The inside would be minus the square root of 3. Then the last would be minus, what's the square root of 3 times square root of 3? It's a 9. Look what happens. Those add up to 0. 1 minus 9 is negative 8. So we took the denominator that had a square root, we multiplied it by its conjugate, and that got rid of the square root. Well, what is an I? An I is a square root, isn't it? Okay, so if you remember that, what if I had something like this? What if I said 2 plus 3i? What we're going to do is we're going to multiply in order to get rid of the I, because sometimes you want to get rid of the I. Sometimes it's in the denominator, okay? And we got to get rid of that I. So if it's in the denominator, what we're going to do is we're going to multiply this by its conjugate. What do you think the conjugate of 2 plus 3i is? It's exactly right. You only change the sign in the middle. Do you see that? This was 1 minus the square root of 3. This is 1 plus the square root of 3. This is 2 plus. We change it to 2 minus. And what's going to happen is that will get rid of the I. Let's do the FOIL on this, and let's see if it really does get rid of the I. Okay? Everybody with me? Let's FOIL this. 2 times 2, 4. That's the first. The outside is what? Negative 6i. The inside is positive 6i. That's going to go to 0. What's this going to be? Minus 9i squared. But Mr. Hamrick, I thought you said that was going to get rid of the I. It did, didn't it? Because look, that canceled. What is that I squared? It's a negative 1. So this is going to be 4. What's negative 9 times negative 1? Positive 9, and that gives you what? 13. So multiplying those two complex numbers together gives you one nice little real number. So we actually took something that was kind of hard, and we made it nice and easy.
Because there's a minus after 4. So
No, because that's with this negative 6i. Okay, that's why these two canceled out. Okay? Make sense? Let's do one more. I got 2 minutes, so I can do one more. No, I got a minute, so you're going to wait until I'm done. Here's where it comes into practice. Why are we packing up? Look, this is where it comes into practice. Can I write my answer like this? No, because there's an I in the denominator, which means there's a what in the denominator? A square root. So how do I get rid of that square root in the denominator? Multiply it by, no, it's conjugate. And you do the same thing to the top. Watch quickly, I'll do this real fast. What's the top going to be? It's just going to be 3 minus 4i. What's the bottom? Do the FOIL. That's 9. The outside and inside add up to 0, and then I get minus 16i squared. But what's the I squared going to do? That's going to be a negative 1, which makes this a what? Plus. So here's your answer. 3 minus 4i over 25, and that's how you would simplify that. All right, I'm not going to give you homework. We got some more to do, but I'll give you some homework tomorrow.